Look up tonight, really look. Past the city lights, past the moon, past everything familiar. Imagine pointing a telescope, not just anywhere, but 124 light-years away. A distance so vast, the light reaching us now started its journey when your great-great-grandparents were young. Now imagine finding something there. Not just rock, not just ice, but a whisper. A potential breath held in the alien air of a world utterly unlike our own. This isn't science fiction. This is the story shaking the foundations of astronomy right now. The story of exoplanet K2-18b, and a single molecule detected in its atmosphere. A molecule that, here on Earth, screams one thing. For decades, we've scanned the heavens, listening for a signal, searching for a twin of Earth. We dreamed of finding another blue marble orbiting another yellow sun. We were looking for a mirror. Then came the news. Late 2023, early 2024, refined data culminating in what felt like a thunderclap in the quiet labs of Earth in the spring of 2025. The James Webb Space Telescope, our most powerful eye in the sky, stared at K2-18b, and it found something unexpected. Dimethyl Sulfide, DMS. DMS doesn't sound like much, does it? But here on our world, it's the scent of the sea. It's released by tiny phytoplankton, microscopic life teeming in our oceans. Overwhelmingly on Earth, DMS means biology. But the JWST didn't just find a trace of DMS on K2-18b. The concentration they detected, it was 20 times higher than the background levels here. 20 times. That's not a fluke. That's not a whisper anymore. That's a potential shout across the light years. A continuous, powerful source pumping this stuff into the atmosphere. What kind of source? The implications, they're staggering. Could it be life? Not like us, something utterly alien? So what is this place sending us, this cosmic message? K2-18b isn't Earth 2.0, forget that. It orbits a red dwarf star K2-18, smaller, cooler, dimmer than our Sun, 124 light-years away in Leo. We first spotted it in 2015, a shadow crossing its star thanks to the Kepler telescope. It's a sub-Neptune, a giant, nearly 9 times the mass of Earth, over twice as wide. We don't have anything like it in our solar system. It huddles close to its dim star, completing a year in just 33 Earth days. Yet because the star is so cool, the planet sits in the habitable zone, the region where liquid water could exist. But water needs an atmosphere, and K2-18b's atmosphere? This is where it gets truly weird. Forget nitrogen and oxygen, JWST confirmed it's hydrogen-rich. Thick, dominated by hydrogen. Imagine breathing that. We initially thought life needed an Earth-like atmosphere. K2-18b challenges everything. Could life exist breathing hydrogen beneath skies utterly alien to us? The JWST also found methane and carbon dioxide greenhouse gases, adding fuel to a radical idea that K2-18b might be a Hycean world. Hycean, hydrogen atmosphere, planet-girdling ocean. A world of water, maybe miles deep, capped by a hydrogen sky. The potential DMS source, maybe not phytoplankton as we know it, but something thriving in that alien deep. The clues have been trickling in for years. Kepler gave us the shadow. Hubble, in 2019, gave us the first tantalizing hint of water vapor sparking hope. Then came Webb, the game-changer. Its infrared eyes pierced the haze. Late 2023, methane and CO2 confirmed. The Hycean model looks stronger. Absence of ammonia, another curious piece of the puzzle. Webb works like cosmic forensics. It analyzes the starlight filtering through the planet's atmosphere. Different molecules block different colors of light, leaving a unique fingerprint, a spectral signature. Webb reads those signatures, and then the DMS signature. Clear, strong, and that 20x concentration. Scientists scrambled. Could volcanoes produce this much? Unlikely in a hydrogen atmosphere. Could strange chemical reactions mimic it? Possible, but hard to explain the sheer volume. The simplest explanation, the one that fits the data best, however strange, was biological. Think about it. On Earth, life fills every niche. Why assume alien life would need our exact conditions? Maybe hydrogen oceans under red dwarf suns are perfectly cozy homes for something else. Something that breathes hydrogen and exhales dimethyl sulfide. This discovery, if confirmed, does more than just point to potential life 124 light-years away. It forces us to rewrite the rulebook for finding it. Red dwarf stars like K2-18 are the most common type of star in our galaxy. Billions, perhaps trillions of them. And estimates suggest up to 80% might have planets in their habitable zones. We've been searching under the lamppost, looking for copies of ourselves. K2-18b shines a light into the vast darkness beyond. It tells us that habitable might mean hydrogen-rich atmospheres. It might mean sub-Neptune giants. It might mean worlds bathed in the dim, red glow of stars, nothing like our sun. The search for extraterrestrial intelligence, SETI, has often focused on signals, on civilizations. But maybe the first sign of life wouldn't be a radio wave. Maybe it would be chemistry. The quiet exhale of a biosphere fundamentally different from ours. K2-18b and its potential DMS puts these Hycean worlds squarely on the map as prime candidates. Maybe the prime candidates. It challenges our definition of life itself. How adaptable can biology be? What bizarre forms could chemistry take on a stage far grander than our single world? Now let's be clear, science demands rigor. This is not definitive proof, not yet. More observations are crucial. Other teams need to verify the findings. We need to rule out every other possibility, no matter how unlikely. That's how science works. It's a meticulous process, not a sudden revelation. There could be unknown geological or atmospheric processes on such an alien world that mimic life's signature. The path from potential biosignature to confirmed life is long and demanding. But even with that caution, something has changed. A door has been cracked open. K2-18b, with its potential ocean-sighing DMS into its hydrogen sky, represents one of the most compelling, tantalizing hints of life beyond Earth we have ever encountered. It's a flashing beacon in the cosmic dark saying, "Look here, think bigger." It propels us into a new era of exploration. An era where we don't just look for Earth's twin, but embrace the staggering diversity the universe might offer. Where we ask not just, are we alone, but what forms does life take out there? The story of K2-18b is still unfolding, but its chapters, written in starlight and spectral lines, are already changing how we see our place in the cosmos. 124 light-years away, an alien ocean might be breathing. And for the first time, we might just be close enough and clever enough to hear it.